In the last class, we discussed linear functions or first-degree functions. In today's lesson, we will discuss quadratic functions or second-degree functions. So a quadratic function is a second-degree function where the highest power of the input variable is 2. And the general form of such an equation is f of x equal to ax squared plus bx plus c, and this is the general form of a quadratic function. Tell me, what will be the form of the graph of this equation? Well, obviously it will not be a straight line. So the next possible graph will be a parabola. Is that right? Yes. So the graph of this we expect to be a parabola. Well, as you have seen before, f of x equal to x squared is the simplest form of a quadratic equation. And what is the graph of that look like? It's a parabola like you have over here. Now, the important thing about a parabola is that it has a turning point. And that's the turning point there. Now, what is the behavior of a parabola? On negative infinity to 0, the function is decreasing. And on 0 to infinity, the function is increasing. And it has a turning point. A turning point comes in between where the function decreases and increases. Is that right? Now, the turning point of a parabola is called its vertex. So here we have the vertex of the parabola. And for this parabola, f of x equal to x squared, the vertex is the origin. The vertex is the point 0, 0. Now, if the parabola moves to the left or right, or up or down, its equation will change. Can you tell me what change will occur? Well, we will come to that after answering this. The graph of f of x equal to negative x squared, you know by now, is the reflection of the graph of f of x squared on the x-axis. So this is the graph of f of x squared, and this is the graph of f of negative x squared. And the graph of f of x equal to ax squared. What is the role of this a? The a actually has several roles. Positive a makes the parabola opens up. Negative a makes it open down. A large value of a makes the parabola flat, and a large value will make it narrow, and a small value of a will make it flat. That's right. Now there you have f of x equal to 0.2 x squared. A is the small quantity. And you have f of x equal to 3x squared, and it is a narrow parabola. All these we discussed already. Okay. Now, this is the question I have been asking you. The vertex of the parabola f of x equal to x squared is 0, 0, the origin. If the parabola is translated h unit horizontally and k units vertically, you get this equation, f of x equal to x minus h all squared plus k. Now, then the ordered pair hk will be the vertex. When the vertex is translated h unit horizontally and k units vertically, that hk, where h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. And so, what is the standard form of a parabola? This is the standard form of a parabola. F of x equal to a times x minus h squared plus k. Now, look at the graph of a general parabola. Now the vertex of this is shifted 3 places to the left and 1, 2, 3, 4, 5 places down. That means your h is -3 and k is -5, and that is the new vertex, which is -3, -5. Now the vertex we call hk, and in this case h is -3, k is -5. Alright, the sign of A determines if the parabola opens up or opens down. Now, another important information about a parabola. If you draw a vertical line cutting the x-axis at h, and we call that x equal to h, what is the significance of this vertical line? Now, this is called the axis of symmetry for the parabola. If you look at the left of the line and the right of the line, the parabola is symmetric. So the line, the vertical line x equal to h, is called the axis of symmetry of the parabola. All right, let's answer a couple of questions. What is the vertex of the parabola f of x equal to x plus 3 all squared minus 5? Now here, this is of the form x minus h all squared plus k. Tell me, what is the value of h in here? Notice that sign is positive. When that sign is positive, h is negative. So h is -3 and k is -5. The vertex is -3, -5. And that is actually the parabola I just drew some time ago for you. This is the vertex, h equal to -3, k equal to -5. And what is the axis of symmetry of this parabola? The line x equal to 3. This line is called x equal to 3. We talked about the equation of a vertical line a couple of classes ago. Is that right? We will now look at another one of these. What is the vertex of the parabola? F of x equal to negative, look at the negative outside, x minus 4 all squared plus 3. Here the value of a is -1, which means the parabola will open down. Alright, tell me, what's the vertex here? The sign is negative here, which means h is positive. H equal to 4 and k equal to 3, and therefore the vertex is 4, 3. Now, look at this. The parabola a is negative, means the parabola opens down. The vertex is h equal to 4, k equal to 3. And the axis of symmetry is the vertical line x equal to 4. Alright, I hope you follow these simple concepts. Okay. Now, we will be now spending some time on sketching the graph of a quadratic function. And I want you to follow these steps. Step 1, use the sign of A to determine whether the graph opens up or down. That's the first step. Second, obtain the vertex hk. Third, obtain the x-intercept. How do you obtain the x-intercept? X-intercept occurs where the function value is 0. So set f of x equal to 0 and solve for x. Then obtain the y-intercept. Of course, y-intercept occurs where x equal to 0, and find the value of the function at x equal to 0. Then obtain the axis of symmetry. Axis of symmetry is always x equal to h. Now, once you have this information, mark the vertex, the x and y intercepts, and draw the axis of symmetry, and use this information to sketch the best possible parabola. Alright, let's practice some examples. Draw the graph of the quadratic function f of x equal to 2 times x minus 2 all squared minus 2. All right, tell me, will this parabola open up or down? A is positive, the parabola opens up. Will it be a narrow or a broader parabola than the standard one? A equal to 2, it will be slightly narrower. All right, what is the vertex? The vertex, your h equal to 2, positive 2, because the sign is negative. K equal to negative 2. The vertex is 2, negative 2. Our third step is obtain the x-intercept. To obtain the x-intercept, take the function, set it equal to 0, and solve for x. Can you solve this for x if I leave it for you? What will you do to solve this for x? Well, first of all, take this negative 2 to the right side. It will become now 2 times x minus 2 all squared equal to 2. Now, divide both sides by 2. That will give you x minus 2 all squared equal to 1. What will you do to solve now? X minus 2 all squared equal to 2. Take the square root of both sides. Now what will you get? Square root of the left hand side equal to square root of the right hand side. Tell me, what is the square root of 1? The square root of 1 has 2 values. It could be plus 1 or minus 1. That's right. So, square root of the left-hand side is x minus 2. Square root of the right-hand side is plus or minus 1. Square root 1, because negative 1 squared is 1. Positive 1 squared also is 1. Alright, that means there are 2 values of x. So, first we say x minus 2 equal to positive 1. And that will give you x equal to 3. That is one x-intercept. The second x-intercept is obtained by saying x minus 2 equal to negative 1. You see that? We take the values one by one and solve for x each time. X minus 2 equal to negative 1 will give you x equal to negative 1. And move this negative 2 from the left to the right, become positive 2. Negative 1 plus 2 is 1. And how do you now write the x-intercepts? The first x-intercept is x equal to 1, y equal to 0, that is this one. The second is x equal to 3, y equal to 0. That means the graph of this parabola will cut the x-axis at 2 points. Alright, what is the y-intercept? Y-intercept is obtained by putting x equal to 0, f of 0. And that will be 2 times, replace x by 0, 0 minus 2 all squared minus 2. And that will be, watch this, 0 minus 2 is negative 2. Negative 2 squared is positive 4. 4 times 2 is 8. 8 minus 2 is 6. So the y-intercept is 0, 6. Now watch the way I write each intercept as an ordered pair. Very important there. And what is the axis of symmetry? The line x equal to 2 is the axis of symmetry. Now do we have enough information? We can now mark all these on the graph paper. What is the first thing to mark? The vertex is 2, negative 2. That's where x equal to 2, y equal to 2, that is the vertex. There is an x-intercept that is 1, 0, that is there. Another x-intercept that is 3, 0, there. And we know that the vertical line x equal to 2 is an axis of symmetry. Also we know the y-intercept is 0, 6. That is the y-intercept. So you can now actually plot that parabola, knowing that this is the axis of symmetry. Alright, so we have the sketch of the parabola with all these informations. I'm sure you can now use this to plot the graph of any second degree equations. Follow the 6 steps. Alright, let's try another one. Draw the graph of the quadratic function f of x equal to x minus 3 all squared plus 2. Alright, what's the first thing? What's the value of a here? A is positive 1, which means the parabola opens up. The second information is the vertex. Tell me, what is the vertex of this parabola? The vertex is h equal to 3, k equal to 2. Therefore, vertex is the point 3, 2. Alright, now we find the x-intercept. Okay, to find the x-intercept, we take the function and set it equal to 0. Can you solve it for me? Well, to solve it, first we take this positive 2 from the left to the right. That gives me x minus 3 all squared equal to negative 2. Now, there is something wrong with that equation. Can you tell me what is wrong with that equation? X minus 3 all squared equal to negative 2. Can the square of a quantity be equal to a negative number? No, that is what is wrong there. Now, therefore, what do we do? What is the information that actually gives you? The information this gives you is that since this is not possible, x minus 3 all squared equal to negative 2 is not possible, there are no x-intercepts. In other words, this parabola will not cut the x-axis. That is the meaning of that. So, since this is not possible, because a square of a quantity cannot be 0, there are no x-intercepts. And find the y-intercept. Of course, the y-intercept is f of 0. Alright, go up to the function and tell me what that is. When x equal to 0, 0 minus 3 all squared is 9. 9 plus 2 is 11. So the y-intercept is 0, 11. And the axis of symmetry is x equal to h, x equal to 3. The parabola will be symmetric about the line, the vertical line, x equal to 3. Alright, let's mark these points. Our vertex is x equal to 3, y equal to 2. That's the vertex. And we have no x-intercept, but we have a y-intercept. Y-intercept is 0, 11. And this is the axis of symmetry. Now, axis of symmetry can actually be used to our advantage. Look at this. If 0, 11 is a point on the parabola, there must be a symmetric point on the parabola here. And what will that be? That will be 6, 11. Is that right? If this distance is 3, then you go another 3 from the line, the function value must be the same. So if 0, 11 is a point on the parabola, then 6, 11 will also be a point on the parabola. Now, knowing that, you can see point of symmetry. That is, if you reflect that point about the line of symmetry, you get the point 6, 11. So once you have the point of symmetry, you can draw your parabola. And that is the advantage of drawing the axis of symmetry. If you have one point on the left, there will be a corresponding point on the right, exactly equidistant. Okay, another one. Draw the graph of the quadratic function f of x equal to negative x minus 1 all squared plus 9. Tell me the first information. A is negative, therefore the parabola opens down. The vertex is h equal to 1, k equal to 9, it is 1, 9. And to find the x-intercept, we set the function equal to 0, negative x minus 1 all squared equal plus 9 equal to 0. Now that means, first of all, you take 9 to the other side, it will become negative 9, and divide both sides by negative 1, and you get x minus 1 all squared equal to 9. I hope you understood this. If you keep the 9 on the left hand side and take this negative quantity to the right hand side, it will become a positive quantity. So x minus 1 all squared equal to 9. Alright, can you solve for this? Take the square root of both sides. And what will you get? The square root of the left hand side is x minus 1. And the square root of the right hand side is plus or minus 3. So you get x minus 1 equal to plus or minus 3. And now take x minus 1 equal to plus 3, solve for x. Then take x minus 1 equal to negative 3 and solve for x. So x minus 1 equal to positive 3 gives you x equal to 4. And x minus 1 equal to negative 3 will give you x equal to what? Are you thinking? X equal to negative 2. So what are the x-intercepts? The first x-intercept is negative 2, 0. The second is 4, 0. These are the x-intercepts. Alright, let's find the y-intercept. Y-intercept occurs when x equal to 0. When x equal to 0, 0 minus 1 squared is 1. And that will be negative 1 plus 9 equal to 8. So f of 0 is negative 1 plus 9 equal to 8. Now, if you have a doubt, you stop the video and look at it and spend some time with it. And so the y-intercept is 0, 8. What is the axis of symmetry? The axis of symmetry is the line, the vertical line, x equal to 1. And now let's mark all these points. You have the vertex 1, 9, h equal to 1, k equal to 9. That is the vertex. The x-intercepts, there is an x-intercept at negative 2, 0, that is 1. There is another x-intercept at 4, 0. And where is the y-intercept? Y-intercept is 0, 8. Here is the y-intercept. And what other information do we have? The axis of symmetry is the line x equal to 1. And now we have all the information we need to plot that graph. If you want, you can actually mark a point of symmetry. If 0, 8 is the point on the graph, and that point is 1 unit to the left, there is a similar point 1 unit to the right. That will be what point? That will be 2, 8. This is the point of symmetry to that point. And now you can plot the graph of the parabola. Alright? It's actually a beautiful way to plot the graphs, and you can really enjoy it. When you understand a concept and when you can really do it, and that is the time you really enjoy it. And you really need to enjoy learning math. It is very important that understanding and the enjoyment that understanding gives you. Alright, we will now draw the graph of a quadratic function in the general form. You see, so far we were drawing the graph of quadratic functions in the standard form, which is f of x equal to a times x minus h all squared plus k. What is the advantage of the standard form? It gives you the vertex right away, h and k. But if you have the equation in the general form, what you think is the general form of a quadratic equation? The general form will be ax squared plus bx plus c. That is the general form of a quadratic equation. F of x equal to ax squared plus bx plus c is called the general form of a quadratic. Now here, a is the coefficient of x squared and is called the leading coefficient. Why is it called the leading coefficient? Because x squared is the leading term, the term that has the highest degree. The term that has the highest degree is called the leading term, and the coefficient of that term is called the coefficient of the leading term. Now, if a is positive, then the parabola will open up, and if a is negative, the parabola will open down. Very important information. The general equation does not give you the vertex hk explicitly, but we can actually use an equation to find h and k using these coefficients a, b, and c. That is, look at this, h equal to negative b over 2a. So you can actually calculate h as negative b over 2a, and once you have the value of h, remember h is the x coordinate and k is the corresponding y coordinate. So once you have h, you bring that value of h here in place of x and solve this equation. The corresponding y value will be your k. Did you understand what I said? Well, using the values of a and b, first obtain your h equal to negative b over 2a. Then bring that value of h and replace it for x and calculate the value of y. Y means f of x, and that will be your k, and that will give you hk, the vertex. So k is the value of the function when x equal to h, or k equal to f of h. So you go to the function f of x and find the value of f of h. That will give you k. And to obtain the x-intercept, we set the function f of x equal to 0 and solve. And many times you can do that by simple factoring, or we will use the calculator to do that. And of course the y-intercept is obtained by setting x equal to 0. Of all these, to obtain the y-intercept is the simplest. Okay, we will now use the 6 steps that we developed earlier to draw the graph of a parabola. Now, before that, let me give you some idea on solving a polynomial equation using a TI-83 or TI-84. Now, in this lesson, we need to solve equation of the form ax squared plus bx plus c equal to 0 to find the x-intercept of the graph of the function. Alright, let's practice solving an equation like this on TI-83. Now, I'm not going to show you the TI-83 screen, but I'm going to give you the steps. So take your calculator and work with me. We are going to solve this equation. 2x squared minus 7x minus 4 equal to 0. Is that right? Because we set the function equal to 0 to obtain the x-intercept. Alright, what you need to do is press the blue key called Applications, APPS. Now look for it, and well, I have a calculator here. Well, I don't think it helps you much, but look for where the application, can you see the application key where I'm following? That's the apps. Now we will be using that. So press the application, and what do you do from there? Press down 11 times to access polysimul. Alright? So press the apps key, then down arrow 11 times to reach polysimul. Now this is polysimul. The apps will give you a lot of menu. So the moment you press APPS, then press the down arrow 11 times to reach this polysimult. Then enter 3 times. Once this is highlighted, enter 1, 2, 3, and you will see this screen which asks you degree of polynomial. Alright, now what is the degree of the polynomial? Our degree of the polynomial is 2. So type in 2 and enter. Then in the screen that comes in, type in A2 equal to 2, A1 equal to -7, A0 equal to -4. Now look at that. A1, A2, A1, A0. They come from left to right. So your A2 equal to 2, A1 equal to -7, and A0 equal to -4. And look at that screen. And then I want you to look at the bottom right hand side, solve. So press graph to solve. In fact, the key graph is the same as solving. And there you get x1 equal to -0.5 and x2 equal to 4. What the calculator tells you is that when x equal to -0.5, this function will be 0. And also when x equal to 4, the value of the function is 0. Or these are the x-intercepts. So what are the x-intercepts? -0.5, 0 is one x-intercept, and 4, 0 is the second x-intercept. I want you to practice this one more time. You can play the video again and practice this until you really learn it. Now, alright, let's now solve x squared plus 3x minus 10 equal to 0. Do this on your own and make sure that you understand this. Alright? Okay. Draw the graph of the quadratic function f of x equal to x squared plus 2x minus 8. Alright? First of all, a, the leading coefficient, is positive, therefore the parabola opens up. Now, a equal to 1, b equal to 2, we don't need the value of c. So a equal to 1, b equal to 2. Why do you need the values of a and b? To find the value of h. H equal to -b over 2a. So calculate h as h equal to -b over 2a, which is -2 divided by 2 times 2, and therefore h equal to -1. Now, h is the x-coordinate of the vertex, and therefore, how do you find k? To find k, you take this -1 and use it for x. In other words, find f of -1. F of -1 will give you k. K equal to f of -1, which is -1 all squared plus 2 times -1 minus 8. And that gives you k equal to 1 minus 2 minus 8, and that is -9. And so what is your y-intercept? Or what is your k? Your k is -9. Your h is -1, and your k is -9, and that is your vertex. I hope you understand the process now. Use h equal to -b over 2a to find h. Then take that value of h in the function. Since h equal to -1, your k will be f of -1. Now, next we want to find the x-intercept. X squared plus 2x minus 4 equal to 0. Actually, you don't need the calculator to do that. This can be easily factored. I hope you know how to factor polynomial functions like this. this is x plus 4 times x minus 2 equal to 0. And set each factor to 0. X plus 4 equal to 0 gives x equal to negative 4. And x minus 2 equal to 0 gives x equal to 2. So what are your x-intercepts? The first x-intercept is negative 4, 0. The second is 2, 0. Now we find the y-intercept. Y-intercept is f of 0. So f of 0, you go to the function, set x equal to 0, you get f of 0 is negative 8, and therefore the y-intercept is 0, negative 8. Alright, what is the axis of symmetry? Remember, axis of symmetry is the vertical line called x equal to h. So x equal to negative 1 is the axis of symmetry. Now we can use all these points to draw the graph. Let's do that. Alright, first of all, the vertex is negative 1, negative 9. Negative 1, negative 9 is over here, and that is the vertex, negative 1, negative 9. And you have an x-intercept, negative 4, 0, and another one, 2, 0. There you are, mark all those points. Now we have a y-intercept 0, negative 8, 0, negative 8, this is the y-intercept. And we have the axis of symmetry, x equal to negative 1. Alright, and you can now draw the parabola, and that's as easy as the earlier one that we did. Alright? I want you to stop the video and go back and do this one more time. Do it on your own. Remember, always, math is learned by doing, not by listening. Always do your own. Draw the graph of the quadratic function f of x equal to negative x squared minus 3x plus 4. The first information, the leading coefficient is negative. Therefore, the parabola opens down. And pick the values of a and b. A is negative 1, b is negative 3. And find the value of h. What is h equal to? H equal to negative b over 2a. So that will be negative b. B is negative 3. Therefore, negative b will be negative of negative 3. That will be 3. So this will be 3 over 2a, 2 times negative 1. So negative negative 3 over negative 2, that is negative 1.5. So h is negative 1.5. How do you find k? To find k, we will find f of negative 1.5. F of h will give you k. So in the function, replace x by negative 1.5. Use your calculator to do this. Alright? And I got it as 6.25. Verify it on your calculator. Alright, so the vertex is h equal to negative 1.5 and k equal to 6.26. Well, it doesn't matter because you will not be able to mark as accurately as it is. To find the y-intercept, no, we have only found the vertex. We have to now find the x-intercept. To find the x-intercept, we set the function equal to 0 and solve for x. And this also can be factored. Is negative x plus 1 times x plus 4 equal to 0. Now, I'm assuming that at the pre-calculus level, your factoring skill is good. If your factoring skill is not good, let me know. I hope you know how to factor this. Alright? Let me give you a quick way to factor such simple quadratic functions. Now what you need to do is, now look at the x I am putting. Now factor the first term of the quadratic, negative x squared. can be factored as negative x times positive x. And the last term plus 4 can be factored in many ways. I'm going to factor it as 4 plus 4 times plus 1. Now I want you to look at this. The reason why I have put this cross is that I have factored the first term, negative x times positive x, and the last term is factored as plus 1 times plus 4. Now look at the way I've written it. Why? Now the line is, watch here carefully, if you multiply along the line 4 times negative x and add it to this multiplication, 4 times negative x added to 1 times x, what does that give you? Negative 4x plus x is negative 3x. Now, you need to do this by trial and error. You see, if you want to factor plus 4, you can factor plus 4 as minus 2 times minus 2. If you write minus 2 here and minus 2 here and multiply and add, will you get negative 3x? No. You can also do minus 4 and minus 1. That will also not give you. So do trial and error like this. Factor the first term and write them on the top. Factor the last term and write them at the bottom. Then multiply across and add. You must get the middle term. Now, until you do that, you keep rearranging, and then when you've done, you say, yes, my orientation is right, and look at the way we pick the factors. The first factor is this, negative x plus 1. There you got negative x plus 1. That is the first factor, and the second factor is x plus 4. Alright? Okay, practice that, and that will be very useful in the long run. Alright? So we factored the quadratic equation. You get negative x plus 1 times x plus 4 equal to 0. Set each factor to 0. Negative x plus 1 equal to 0 gives you x equal to 1. Is that right? Yes. And x plus 4 equal to 0 gives you x equal to negative 4. So what are the x-intercepts? The first x-intercept is negative 4, 0. The other one is 1, 0. Well, the y-intercept, find the value of f of 0. F of 0 gives me 4, and therefore y-intercept is 0, 4. And the axis of symmetry is x equal to negative 1.5. And now we can use all these to plot our graph. What are the information we are going to mark? Vertex is negative 1.5, 6.2 something over here. Negative 1.5, 6.26, that is the vertex. Then you have an x-intercept, negative 4, 0, there you are, and 1, 0. We have a y-intercept 0, 4. There you got a y-intercept. You notice that these points are slightly, well, displaced. But that happens when I draw graphs like this. And the axis of symmetry is x equal to negative 1.5. Can you plot that graph now? Yes, that is the graph of this function. Alright, let's move in and continue with the discussion on maximum and minimum values of a quadratic function. You see, a parabola is either increasing, well, decreasing and then increasing, or it could be increasing and then decreasing. That means at some point a parabola will reach either a minimum or a maximum. Is that right? Okay, so the graph of a quadratic function opens up, then its vertex will represent a minimum point. Do you understand that? Well, I'm sure that is understandable. Now here we have the graph of a parabola that opens up. What happens is, as x increases from the left, the function value decreases, reaches a minimum here, and for any increase in x, the function value increases. That means here you have a minimum value for the function. So actually the vertex gives you either a minimum or a maximum depending on whether the parabola opens up or down. That means, say 4, 3 is the vertex of this parabola. Tell me, what is the minimum value of this function? You see, the minimum value of the function is actually 3. Why? Because k value is the function value when x equal to h. I hope you understand that. The k value is the function value when x equal to h. So 3 is the minimum value of the function, and that minimum value occurs when x equal to 4. That's right. So this green parabola opens up, its vertex is 4, f of 4. Look at that. h, k. K is f of h. So the vertex is 4, f of 4, which is 4, 3. So 4 is h, and 3 is f of 4, which is the function value when x equal to 4. When x equal to 4, y equal to 3, and y equal to 3 is the minimum output. There is no output which is lower than that. And this minimum output occurs at x equal to 4. And the minimum value of the function is f of 4. The minimum value is f of 4, and that is equal to 3. On the other hand, if the graph of a quadratic opens down, then its vertex represents a maximum point. Here I have a parabola that opens up. Now, on the left of the vertex, the function value increases, reaches a maximum, and thereafter it decreases. So if I have negative 4, 5 as the vertex of this parabola, what is the maximum value of the function here? The maximum value of the function is 5, and it occurs at x equal to negative 4. Alright? Its vertex is negative 4, 5. That means f of negative 4 equal to 5 is a maximum value of the function. Alright, let's try this problem now. Check if the function f of x equal to 3x squared plus 6x plus 2 has a maximum or a minimum. Find the maximum or minimum of f of x. Find the interval where f is increasing or decreasing, and find its range. Well, you can tell me by looking at this whether it will have a maximum or a minimum. A is positive. A is positive means the parabola opens up. If the parabola opens up, will it have a maximum or a minimum? It has a minimum. Alright, let's pick the data. Here we have f of x is 3x squared plus 6x plus 2, a equal to 3, b equal to 6. The leading coefficient is positive, therefore the parabola opens up. And as a result, the vertex hk represents a minimum point on the graph of fx. Is that right? Yes. And let's calculate that vertex. H equal to negative b over 2a. Negative b, you got b and a. That will be negative 6 over 2 times 3, and that is equal to negative 1. And how do you find k? K is f of h. So take this h value into the function and calculate f of negative 1. F of negative 1, k equal to f of negative 1. That is 3 times negative 1 squared plus 6 times negative 1 plus 2. And do these calculations on your own. Alright? And that gives you k also is negative 1. So the vertex is now h equal to negative 1, k equal to negative 1. Alright, tell me, what is the minimum value of the function? Well, that is the minimum value of the function. So this is the parabola with the vertex negative 1, negative 1. F of negative 1 equal to negative 1 is the minimum value of this function. And if you notice, this is x equal to negative 1, and from negative infinity to negative 1 the function is decreasing, and from negative 1 to infinity the function is increasing. So f of x decreases on negative infinity to negative 1. I hope that is clear. The value decreases, reaches a minimum, and from x equal to negative 1 to infinity the function value increases. That's right. And the range of f of x is that right? Use the TI-83 to find the minimum value of f of x equal to 3x squared plus 6x plus 2. A good skill. I want you to learn it so that you can practice it in the next couple of lessons. Now this is TI-83 screen. Press y equal to and enter the function like this. y1 equal to 3x squared plus 6x plus 2. Now set the window shown like this. X minimum, x maximum. Do this on your own now. Now don't just sit and watch. Do these things on your own. And then press graph and watch the graph. Now here I have the graph of f of x equal to 3x squared plus 6x plus 2. Alright. Now for second trace 3, you have second trace and then the number 3. Press left arrow to move the cursor to the left of the bend. So when you press second trace 3, and after that move the cursor to the left of the bend and enter. Now what you have done is gave the calculator a left bound, because you see the calculator asked you for a left bound. So move the cursor to the left of the bend and enter. That's what you have done. Now the calculator wants a right bound. So what you need to do is use the cursor and take it all the way to the right of the bend. Alright? So use the right arrow to move the cursor to the right of the bend and enter like this. So you have now a left bound and a right bound. Now the calculator needs a guess. Now what is a guess? Move the cursor back to the bend. Alright? And enter. There you are. It tells you the minimum is y equal to negative 1. Can you read that on the screen? Y equal to negative 1. It happens at x equal to negative 1. Now, this is the minimum value of the function. I want to emphasize this once again. The minimum value occurs at x equal to negative 1, and the minimum value of the function is y equal to negative 1. Alright, practice this one more time. Another one. Check if the function f of x equal to negative 2x squared minus 12x plus 3 has a maximum or a minimum. Find the maximum or minimum value, then find the intervals where the function is increasing or decreasing. Well, we will start by picking a and b. A is negative 2, b is negative 12, and that will help us to find the vertex. Now, which way does the parabola open? A is negative, therefore the parabola opens down. Let's calculate h. h equal to negative b over 2a. b is negative 12, therefore negative b is 12, and divided by 2 times a is negative 2, and that will be 12 divided by negative 4, that is negative 3. h is negative 3. How do you find k? K is f of h. So take the h value that is negative 3 and use it in the function. K equal to f of negative 3. That will be 2 times negative 3 squared minus 12 times negative 3 plus 3. And I'm not going to do this calculation for you. And check this on your own and let me know if these are not correct. So k, we got 21. That gives us the vertex is negative 3, 21. Alright, can you answer the question now? The parabola is opening down. That means the vertex represents a maximum value. And what is the maximum value of the function? F of negative 3 equal to 21 is the maximum value of this function. That's right. Now here I have got the graph for you, and it tells you the maximum y equal to 21, and you see this negative 2.9999. Now this is the crazy way the calculator tells you that the maximum occurs at x equal to negative 3. Alright, so don't worry over this. And the function is increasing. Now, what is the interval where the function is increasing? From negative infinity to negative 3, the function is increasing. And from negative 3 to infinity, the function is decreasing. And so, the function increases on negative infinity to negative 3. It decreases on negative 3 to infinity. And the range is the range of the function. Well, I think I give you the from negative infinity all the way to 21. So you must correct the mistake I made in the previous slide where I talked about the range of the function. The minimum value of our previous problem was negative 1. So the range of the problem of the function is negative 1 to infinity. Negative 1 is the minimum, and the function value can be any value up to infinity. So it's negative infinity to 21. There is no value above 21. Okay, another one. When a football is kicked, it travels vertically as well as horizontally. Is that right? When you kick a football, it goes like that. That means it goes up vertically some distance and horizontally some distance. The vertical height h in meters at any time depends on the horizontal distance x it covered, and the function is h of x equal to negative 10x squared over 25 squared plus x. Now this will be a little better understood if you come and do a physics course. Now, at what horizontal distance is the height a maximum? What it means is that what is the value of x when h becomes a maximum? H is the function and x is the independent variable. The x is the input, h is the output here. What is the maximum height reached by the ball? What is the maximum value of the function? Well, hx equal to negative 10x squared over 25 squared plus x is a quadratic. If you look here, if you notice, this is your ax squared plus bx. So a is negative 10 divided by 25 squared, which is negative 10 over 625 is your a. And your b is 1. And so we find the vertex vertex is negative b over 2a, negative b, b is 1, so that would be negative 1 divided by 2 times this quantity. That is 2 times negative 10 over 625. And that is 625 divided by 20. And that is 31.25. Now this is the x value of the vertex. It means this is where the maximum occurs. The maximum occurs at x equal to 31.25. And what is the maximum height? The maximum height is k equal to, this is h of x. So h of 31.25. If you come to this function and replace x by 31.25, you will get the maximum value of the function. That is negative 10 times x squared over 625 plus x. And calculate this on your own. And that gives you 15.625. As the ball goes like this, when x equal to 31.25, the ball is at a maximum height, and that maximum height is 15.625. That's the meaning of that. And the height is maximum when x equal to 31.25. Alright, and here is the graph of the path of that ball. The ball kicks like this. The maximum height is 15.625 and the maximum occurs at 31.25. Now draw the graph of this on your own and check this. Alright. The graph of a quadratic function is given below. Using the information from the graph, obtain the standard form of the function. Alright, here is the graph of a quadratic function. Now what are the information you can get? You can get the vertex. What is the vertex? Vertex is x equal to 6, h equal to 6, k equal to negative, is that right? No, h equal to 5, k equal to negative 6. So the vertex is 5, negative 6. The y-intercept, look at that, the y-intercept is 0, 6. The standard equation is f of x is a times x minus h all squared plus k. Now, you know h, you know k, so put those values in there. That will give you f of x equal to a times x minus 5 all squared minus 6. Well, we need to find the value of a actually. How do you find the value of a? Well, you see, a very important skill. We know a point on the graph of this, and the point is 0, 6. So 0, 6 is a point on the graph, means when x equals 0, the function value is 6. If you use that, we can find the value of a. So the y-intercept is 0, 6 means that f of 0 equal to 6. F of 0 equal to 6. So if you put x equal to 0, the whole thing must be equal to 6. That is, 6 equal to a times 0 minus 5 all squared minus 6. And simplify this. 0 minus 5 is negative 5. Negative 5 squared is 25. So this will be 25a minus 6. 25a minus 6 equal to 6. So we get 25a, therefore equal to 12. And that will give you a equal to 12 over 25. And we will now take it into the equation here. So what is the standard form of our equation? F of x equal to 12 over 25, x minus 5 all squared minus 6. So look at the method we used once again. We used the vertex to replace h and k. Then we said, we know one point on the graph, which is 0, 6. What does that mean? It means when x equal to 0, the function value is 6. Use that to find the value of a. And put it all back, we have the standard equation for that parabola. Okay. And that is the equation of that parabola, which is the same as the one we had. Another one. Find the equation of a quadratic function whose graph has the vertex negative 4, 12 and the y-intercept 0, 4. Is that different from the previous one? Well, we know the vertex, and therefore we can say the standard form is f of x equal to a times x minus h all squared plus k. H is negative 4, k equal to 12, so that will be f of x is a times x minus negative 4 all squared plus 12, and that will make that sign positive. Now, we need to find the value of a. How do you do that? We know that the y-intercept 0, 4 is a point on the graph, which means when x equal to 0, y equal to 4. So we say 4 equal to a times 0 plus 4 squared plus 12. And you can now solve for a. So that will be 4 squared is 16. That is 16a plus 12. What do we have here? 4 equal to 16a plus 12. And that will give you 16a equal to negative 8. Or a equal to negative 1/2. And take it back to your equation and replace it here. That will give you the standard form is f of x equal to negative 1/2. A is negative 1/2. X plus 4 squared plus 12. And that is the standard equation of the parabola that has this vertex and this y-intercept. Alright. Another one. Find the equation of a quadratic function whose graph has this vertex and a point 350 is on the graph. Now, when we say a point 350 is on the graph, what that means is when x equal to 3, y equal to 50. That is the meaning of that. Alright? Use the vertex to write the standard form. F of x is a times x minus h all squared plus k. H equal to 6. K equal to negative 40. And therefore, we have that equation. And what left for us to do is find the value of a. How? Use this given condition that 350 is a point on the graph of the function, which means when you replace x by 3, the function value will be 50. So if this is 50, that x will be 3. Just do that. 50 equal to a times 3 minus 6 all squared minus 40, and solve for a from there. This will be 3 minus 6 is negative 3. Negative 3 squared is 9. That will be 9a minus 40 equal to 50. And taking the negative 40 all the way back there, you get 9a equal to 90, or a equal to 10. And that gives you the standard form. And take a equal to 10 over here. The standard form is f of x equal to x minus 6 all squared minus 40. And finally, let's do an application problem. A farmer wants to construct a fence behind a barn using the long side of the barn as one side of the fence. He has 240 meters of fencing and wants to construct 2 adjacent identical pens. What dimensions should he use to get the maximum area enclosed? I want you to read this and get a picture of the problem. Now, here is the This is the side of the barn, and he wants to make a fence here using one side of the barn. Is that right? He wants a fence behind the barn using the long side of the barn as one of the sides. This is the long side of the barn as one of the sides. And this is the fence. And he has to have two compartments. Is that right? Yes. He wants to construct two adjacent identical pens. There you are. And what dimension should he use to get the maximum area enclosed? Now, what is the given information? Given information is the total length of the fence he has is 240 meters. In other words, if you add this length to this length to this length to this length, it must be equal to 240 meters. That is what is given. So let's write that down. If this is x, then this will be x, and that will be x, and let that length be y, which is the length of the barn actually. So let the length of the fence be y and its width be x. Then the total length of the fencing, look at that. Total length of the fencing is y plus x plus x plus x, which is 3x plus y. And that 3x plus y should be equal to 240, because that is the amount of fencing that he has. And solve this equation for y. Therefore, y equal to 240 minus 3x. Alright, we have now established a relation. Now, we need to see what is the equation we need to set up. We were told what dimension should he use. In other words, we need to find the values of actually x and y, so that we need to get the maximum area. We need to maximize the area. That means we need to now write area as a function of one of these. Can you write what is the area of this pen? Well, the area will be, isn't it, length multiplied by width, x times y? Yes, x multiplied by y will be the area. So the area is x times y. But we cannot deal with two variables. We must eliminate one variable and write area as a function of just one variable. And that is where this information helps. You know that y equal to 240 minus 3x. So replace this y in the area equation by this. So we have a equal to x times 240 minus 3x. Now we've got area as a function of x. And now we are able to obtain the maximum conditions and apply it. So look at the way I write the function now. A of x equal to negative 3x squared plus 240x. We want to find the maximum value of this area, and we want to know when the area becomes maximum, what is the value of x. This is a quadratic function, and the answer to that question is the vertex. So we need to find the vertex, that is all. So a equal to negative 3, b equal to 240. Find the vertex. H equal to negative b over 2a, negative 240 divided by 2 times negative 3, and that will be 40. H equal to 40. What it tells you is that this a becomes maximum when this x equal to 40. And when x equal to 40, what is the maximum value of the function? K equal to f of h. In other words, take this 40 into this function. That will be f of 40, and that will be negative 3 times 40 squared plus 240 minus 40, that is 4,800 square feet or square meter, whatever that is. So the maximum area is 4,800, and the area becomes maximum when x equal to 40 meter. Now when x equal to 40, what is the value of y? You can find the value of y there. So this is the vertex 40, 4,800. And when x equal to 40 meter, y equal to 240 minus 3 times 40, that will be 120 meter.